ready to start here. Talk today is on decompilation and application security and how it can change your life. A little bit about myself. My name is Kevin Spett. I work at Spy Labs, which is the research and development arm of Spy Dynamics Incorporated. We are the world's leader in web application security technologies. We make an assessment tool called Web Inspect. In the labs, at Spy Labs, we do stuff. We look at emerging issues in the application security field. And one of the things that is a really great thing you can do, but I don't think has been talked about enough, is decompilation. The goal of this presentation is not to explain the technical minutia behind what decompilation, how it actually works. If you want to know that, download the JVM spec from Sun. It'll basically tell you how to read JVM shellcode, which is what decompilation is. It just looks at that and it says, this is about what this would look like in source code. Presentation here is divided into two parts. The first thing, I'm just going to introduce what decompilation is, a couple of quick ways to use it, and then after that we're going to get to the fun part, which is how I used it to find a vulnerability in BA WebLogic. The other thing you guys should know is that if you are following on the slides in the red book, you are going to see different stuff up here. It has been revised. The most recent slides will be available on the Black Hat site afterwards. So let's get started. All right, first question is, what is decompilation? In a sentence, decompilation is a way of getting to source code to applications that are only distributed in executable form. Decompiler is a rig surprise, a program that automates the process of decompilation so that you don't have to do it by hand. A lot of languages decompile really well. There are ones for Visual Basic, Java, .NET. There are two that I know of right now. There are probably going to be more. And something that, again, hasn't been mentioned much, .NET applications can be decompiled, and you can see their source code in most cases. There is a thing, though, that some languages decompile better than others. Java, for instance, happens to work exceptionally well. The reasons for this are basically the same reasons that make Java an attractive language to do enterprise development in. It uses fewer lines of code, which basically means there's less stuff going on. You can accomplish more in a few lines of Java or any other high-level programming language than you could in C. Also, Java applications tend to make extensive use of reusable, widely distributed components, so you have fewer and fewer people rolling their own things that are annoying to go through and figure out how they work. When you're looking at a Java application and it wants to open a file, pretty much every Java application is going to do it in about the same way. Java is completely portable, again, as one of its strong points. So there aren't processor-specific issues that you would have to go through. You've got one executable no matter where you want to run it. So you only have to do the decompilation analysis really once. And really, the real killer is here that the whole thing works in intermediate bytecode. VM code is very clean looking. The JVM does a lot of the work in terms of things like memory management, and all that stuff that in a language like C or C++, their executables would take a lot of work to sort out in the decompilation process. You simply just don't really have to worry about it when you're working in Java. Tools that are available, Mocha was probably the first widely distributed Java decompiler. It worked well for a while. It's no longer being maintained. In fact, I think the author is dead. It's somewhat buggy, and seeing as its author is dead, it is not likely to get repaired anytime soon. JAD, which is currently my personal favorite, is very fast. It's written in C, which is nice if you're decompiling a very large code base, for example, an entire servers. It's available on a lot of different platforms. You can get it for OS X, you can get it for Windows, you can get it for Linux, for Solaris. If you like things that are fancy, there are nice standalone GUIs for it. There's a plugin for Eclipse for it, written by some Japanese guy that I cannot get to work because I can't read the documentation for it, and it looks like it's broken. But the caveat for it is there is no source code. Third one I'm going to mention is Jode. It is open source, hosted on SourceForge. It is still actively being maintained, and it is written entirely in Java. I've had not great luck with Jode. JAD is still my personal favorite. Okay, now that we know we can decompile stuff, some ideas for targets, things you might want to look at. What should I decompile? Clients. There are a lot of thick Java clients out there, either in the form of applets, for instance, or standalone applications. A lot of people may use Java clients. The people who build these Java clients really don't expect that people are going to take them apart and see how they work and the things they do. Good examples of Java clients is there was one I had a friend tell me about for a casino that he took apart. And as it turned out, we looked through the code and you could see other players' hands if you just decompiled it, looked through the Java code, and see what the thing was capable of, which is a great black box strategy. I haven't tried it here, but don't think it would work. Second thing is stolen class files. If you're doing a web app audit and the servers are using servlets or Java server pages, somewhere on that server, quite possibly on the file system, there are class files. Class files, the Java executable, it's what you decompile. You can go grab those and you can take them apart and see what those JSPs or servlet pages are doing. And finally, we can look at servers. WebSphere is written in Java. WebLogic is written in Java. Sun1 is written in Java. JRun is written on Java. These are applications that power a lot of the world's largest enterprise businesses. And they're all written in this language that you can basically very easily, using tools that are freely available, take apart and see how they work. Which brings us to BEA. BEA WebLogic is a pretty popular application server. A ton of the Fortune 550 companies use it. It's out there all the time. And a while ago, we sat down and we decided we wanted to see what WebLogic does, and we did an audit of it, and we found some interesting stuff. Next part of the presentation here is going to be a rundown on an excerpt of the things we did and one of the vulnerabilities we found that involved decompilation. I just want to mention at this point that a lot of stuff is changing right now in the way that people are going to be hacking in the next few years. Is that you're not going to find a buffer overflow in WebLogic. The entire thing's written in Java, and even if you could pull off some magic, I mean, you're inside the virtual machine. There's not a whole lot you're going to do. You're going to have to look for other ways to get into things besides shellcode. One of the great ways of doing it is decompiling stuff and seeing all the stupid things developers did that they figured no one would ever find. And with that, started with regular install of BA WebLogic on Windows. You'll note I put up here in very large letters for a reason that will be very soon apparent. It basically says we're installing a WebLogic domain and there's no template applications on it, no custom applications. So, we installed the server, and the very first thing I wanted to do is just see what it had running on it. Now, the documentation for BEA WebLogic, it mentions that there are two applications on the server. One of them is administration console, which is this. Other one is a certificate application. It's behind off. But the point is, there's stuff on the server. So instead of starting by decompiling the actual server engine, which is probably somewhat complicated, let's just look at the things that are easier. For instance, the console application. Windows Server 2003 was just released. For those of you who read Bug Track, which is probably just about everyone, someone looked at the console application for the Windows IIS 2003, whatever, and found that it had some holes in it you can march an elephant through. People don't pay a lot of attention to these things. So on a web app server, the place you look for to see what is deployed is in config.xml file. This is the one, what it basically looks like for a default WebLogic install. You've got encryption keys, realms for authentication, and these things, application deployed. That's the whole entire XML file. There's only one of them. There are two applications deployed here. One is called default web app, and one is called certificate. But that's kind of interesting, because know for a fact here that there's a console application. So I was thinking, it's not in the config.xml file, but it's definitely live on the server. So where is this thing? So I head over here, and Java applications are typically deployed in war files, which is basically a zip file that contains some Java stuff. And look at that. There is a directory in my server, which is the name of the server instance, called .internal, and that's where console.war is hiding out. So we're going to head over there and see what's going on in here. By the way, can everyone see that okay? No, great. All right. Well, I just did a find for console.war, and it located it. And I changed to that directory. Let me see if I can make the console larger here. Okay, that made the console larger, the font's still small. Yep. Here we go. No. Is that better? All right, so, hold on. More? We can keep going. I don't know how big these fonts get, but we're going to find out. I'm not changing the font color. Here's 16 by 12. Whoa. That takes too much time and effort. I tell you what, I'll give you guys really good descriptions of what I'm doing. This is an LSL command. I'm seeing what is in the directory. There are, not only is console in here, but there are a number of other applications that the documentation says nothing about that are in this .internal directory. There is console.war, which is documented, and we saw a moment ago, starts with the login screen. There's something called UDDI, another thing called UDDI Explorer, which both looked at and have some very interesting stuff in them. Those are both web services related. And there are these things here called WL Management Internal 1 and WL Management Internal 2. That sounded pretty interesting to me at that point. I did a Google search on it. There is nothing on the web about WL Management Internal in any of the B administrator docs or anything. So the only way to learn about them is to take them apart and see what they do. Process of decompiling this stuff is really simple. You just start by unzipping these things to a directory. Cannot find file WL management .war. Okay, problem solved. So I'm going to the directory where I just unzipped this WAR file. Again, a WAR file is basically a zip file format that contains Java files. We're going to see what's in here. There's a webinf directory and a meta-inf directory. Webinf is interesting. If you're looking at a web app, there's a file called web.xml, which explains how to get at that web app from a browser. This is what WL Management Internal 1 looks like when you request it. This is the web.xml file for it. As you can see, it deploys one servlet. It is called log file search. Log file search sounds pretty interesting to me. We're going to decompile it. Okay, JAD's there. JAD is one that's written in C. I'm very happy with it for the most part. It's very easy to use. For instance, you just go to the directory with the files you want, or wherever the directory is, jadstar.class, or no matching files found. What's in here? Oh, this is the web.xml directory where this file is that tells us that there's login search. We're going to the classes directory. And here we have two Java class files. One is called log file search servlet, which is the one that's deployed, and the other one is called Weblogic log message. Since Weblogic log message isn't deployed, it's safe to say this is probably something that's just used by log file search. Okay, so that's the JAD output. Now we look at the directory again, and we've got two files called .jad that are Java source code. Okay, so this is what we just walked through. Two applications, and we will have these management internal things. And it had two Java files in it and one XML file. We looked at those, and now let's decompile and see what's in there. This is going to be absolutely unreadable for you guys. I'm going to have to do something about this. It doesn't look very large. It just sucks. I'll have Spike Proxy loaded in just a minute to complete the rest of this presentation. For those of you who haven't used Spike Proxy, it can do everything and anything. Anyway, Hopefully that's a little better. This looks pretty much like any Java source code file you've ever seen. Up here it's got a little JAD header explaining what it did, where it came from, and we've got all this stuff in here. In a servlet, servlets are handled when you make an HTTP request. You get generally two handlers for the servlet. You've got one called doGet and doPost, and these are the ones that are interesting to us because that's where we can do things. So here's the doGet handler for the log file search servlet, which is an undocumented application that's deployed in all BA WebLogic servers. First thing it does is grabs two headers, a header called username and a header name called password, and it's going to get the value of those. Now that's kind of weird because using headers like that to exchange authentication is not standard. So at this point, I'm pretty sure they're doing stuff and they're not entirely doing things right. There's a reason that they're passing these in headers and not using real web auth, using HTTP auth or something on application level. This is pretty weird. So it takes a username and password and it sets up, and this block of code right here basically does authentication. And if you log in incorrectly, you will get 401, as we see over here, because it doesn't have these headers. At this point, I basically decided that it looks like if they're doing authentication, I'm going to need a username and password. Let's move on, see if we can find something else. So I was like, okay, what does WL Management Internal 2 do? Since there were two of those things. And now we're going to do the same thing again. You would unzip WL Management Internal 2, and then you would run jan on the class files, which I have already done. So we're going to go here, and this is what WL Management Internal 2 looks like. Again, it's got 403 on it, which is kind of discouraging, but we're going to look at it anyway. So we go to WL Management Internal 2.xml. And this has got a couple of things deployed on it. There is one servlet called Bootstrap, and there's another one called File Distribution Servlet. At that point, I was pretty intrigued. So we take apart, and in the same way you would, you'd go to the directory with the class files, and you'd go get the File Distribution Servlet, and you decompile it, and you got another one of these files. So we're going to do the same thing here. We're going to look for the servlet handlers, doGet and doPost. So the file distribution handler for the doPost method, which is the first thing we're going to look at, is that, again, there's more really weird stuff going on where, for whatever reason, they're exchanging information through HTTP headers. Now, when you use something like Internet Explorer, you don't really have much access to change the headers without doing weird stuff to the DOM. Someone's probably found a way to do it. But it's pretty obvious that whatever these things that it's getting the headers for, like WL request type, is they don't expect an actual user to be doing this because users aren't going to start changing the headers like that. This is obviously something they've set up for internal communication within WebLogic. So this is basically a servlet that an application would be talking to, not like a user in front of a web browser, which is probably why it's named WL Management Internal. And it goes through, and in this one, again, it's doing authentication. It's got the same thing here, get header, username, and get header password. And you'll look that even though this does look like it's protected by auth, there's something called WL upload application name here that I will mention a little later because it's pretty interesting. But we're going to look at the doGet header now. So we've already seen that there are two of them, which is a little bit unusual, but not too much. Here's the doGet handler. Again, communication and headers. It looks for a header called WL request type. And depending on the value of what that is, it does a whole bunch of stuff. So If your header is equal to WL component request, it calls this function. If it's WL or resource request, it calls this one. We are going to look at all these WL request type things. There are 10 of them. And if you look at these, see the ones marked with the star on the slide, those are the only ones that do authentication. It's got it there, and it's got it at other points in it, see the username and password, but not for all of them. Some of them will just call these functions if you ask for them. We're going to look at the one called WL XML entity request. Let's see. We're going to go back. Get XML entity request. So it's calling this function, and we have these headers that we use: XML registry name and XML registry path. So to just step back and review here, we've got an application called WL Management Internal 2, and it's got a servlet called WL Management deployed. And if we put the header WL XML request, it's going to look at these things. I like to push buttons, so at this point I'm like, okay, what do these things do? What happens when I start filling stuff in? So this tool I'm using, it's just an HTTP request editor. It's part of WebInspect, the software we make. So I send this request, and it comes back with the error message. It's HTTP code 500, an internal server error. And that text, that line at the bottom says, XML registry directory, C BEA user projects my domain, dot space backslash XML registries, and then the garbage I typed, not found. This is pretty cool because it looks like it's using all the stuff I'm putting up here in the headers. It's using it to build a file system path that presumably it might be trying to load. So we're going to look more into this. So it goes through, in that source code, it gets the values in the headers for XML registry name and XML registry path. If both of those are non-null and not zero length, it creates an object called an XML registry dir with the value of XML registry name. And then it calls a method on it with the value of the XML registry path. So basically, when you hand it these two arguments and headers, it creates an object and calls a method using the values you did. XML registry dir is not an object that's in that source code file, so we're going to have to go look for it. At this point, did some work that you're not going to see in the presentation because it'd be a waste of time to show you. Weblogic has a file called weblogic.jar, which contains more or less all of the classes that Weblogic use, and XML registry dir is in there. And I'm going to show it to you here. So I've already found it and decompiled it in the same way that we did the other thing. You just unzip the file and decompile the classes you want. So the first thing we looked at is that in the source code for file distribution servlet, it creates an XML registry dir with string s. This is the constructor for that. And basically what it does is it takes it, and if all this stuff works out okay, it'll go through and set it to the registry name, because registry name is a variable, and it's equal to whatever you passed into the string for the constructor, which is this value right here, XML registry name. Next thing the application did is called getEntity with another value. That was the value of XML registry path. And it will call getLocalEntity. So let's see what it does here. File equals new file, S1, XML registries plus XML registry name. So what it's doing is it is indeed exactly what it would look like here from this error message. It's taking whatever we put in here, and it's going to load a file based on this. And you'll note that it never did any kind of validation of your input. It didn't try to strip out double dots or all these things. Never mind that when most people do it, they do it wrong anyway, and there are ways to circumvent them. But it just doesn't look like anyone really paid attention to the fact that you can ask for whatever you want. So we go through here, and we look at what do we have. So, well, there is an undocumented application called WL Management Internal 2. It is deployed in the most basic configuration of a WebLogic server. It's got a servlet called file distribution, which does a bunch of different stuff depending on a value you send it in the headers. It doesn't use authentication on most of them. One of the file distribution servlet's functions, WL XML entity request, can take two client-supplied values and they'll use it to put together a path. And then after that, as you look in the source code here, it returns a file input stream with whatever came out of that call. So it is sending whatever the result of that is back to the user. So we end up with a request that looks like this. Since it builds it around the XML registries directory, we're going to have to traverse out of it using those double dots and slashes, since it doesn't mind, it doesn't try to block it. And let's say the file we want is config.xml, which we already looked at because we have access to the server, but normally you can't touch it. It's in the webinf directory, which is supposedly protected on web app servers. So we send off this request, and surprise, surprise, we do get the config.xml file returned. Config.xml files are really nice if the web application uses database access, which almost all of them do. The database connection information, login name, password is usually stored in here. Crypto keys, all kinds of other little settings. I'll show you another thing here, which is really cool. If the server really isn't configured right, it doesn't stop with what's inside that web application. Yep. Three dots. Thank you. That's the boot.ini file. So at this point, we have one of the world's most popular web application servers for large enterprises that has this undocumented application that basically lets anyone who asks for it pull files off the system. I will tell you guys other things, that there are all kinds of other stuff that these applications do. That I just showed you one of them, WL XML entity request. This is, by the way, this is a released bug. They fixed it a while ago. Most people didn't bother patching. So this is very useful stuff. If you go through and you walk through the procedure I did and you take a time to look at everything that those source files do, there are ways to upload applications to the server. There are ways of getting the complete source code to the applications. It'll actually send it back to you in a WAR file format. For those of you who don't know, that you can go to the BEA website and download the installer for this. You can actually download a vulnerable version. I don't know why they're still on their website, but they are out there. So you can walk through this presentation and see what it did and find all the other stuff. At this point, I'm going to open up the room for questions. If anyone has any questions about application security in general, what went on here, please feel free to ask. Yes? Well, preventing Java decompilation is, there are tools called obfuscators that do things that are known to kind of break decompilation tools. Some of them work pretty well, some of them don't. But at the end of the day, the truth is you've got to write good code. You can't put stuff in there and assume no one will ever find it. It's the solution, and it's not an easy one, but it's the right one. Yes?
What was the vendor's response about you reverse engineering this?
BEA Weblogic was very alarmed that they had these problems in their code, and they worked with me. They created a patch for it, took it apart. There was no backlash. There was no, why are you doing this, you know, blah, 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 blah. They were very receptive to the fact that people are going to be going through their stuff looking for problems.
Are you a little worried about the legal problems? Because this isn't just like black boxing, right? This is, you're going after the intellectual.
Well, the laws that would be used to prevent this are specifically designed for the circumvention of copyright controls. This really isn't a copyright control issue. Furthermore, supposedly security research is protected. What I feel I'm doing is legitimate. If they don't like it, you know, it's not my problem. I'm here to share knowledge. Other questions? Okay, well, thank you all for your time. Have a lovely convention.